Hello, Emmanuel. Now today we make this testing for Czechoslovakia fuel level sensor model HPT604FW. Now you can see I have been connection the fuel sensor to software, and also now it's power on. Please check the computer screen. I have made a table to show you the relation for different fuel density. Now you can see okay. Now this table you can see the left is our sensor calibrated density 0.85, and the rest is different level data. Okay, for example 500 millimeter. You can see the middle column is 0.84 dizzy level density. Okay, the right is the water level density 1.0. So this is the three different density and the relation. So it means now sensor is 500 millimeter 0.85. So the water level should be 425 millimeter. Okay, so you can see the software display 500 millimeter 0.5 density. So the water tank should be 425 millimeter. Okay, let me check if it is 425. Okay, let me check. Yeah, can you see? 425 millimeter. This tank scale is cm 42.5 water level. So sensor is correct display. Okay, now I ask our engineer to use a pump to solve the dizzy level to okay, please put water to 506. Okay, this is the sensor's display 0.85 density. Okay, let me check the water tank level should be 430. 506 relation to water level is 430. Okay, let me check tank. Okay, it's 43 cm. It means it's 430 millimeter water level. So display 506 fuel level. Okay, this fuel level is based on the density 0.85. Now we are continue to increase, to add water to 518 millimeter. 518. Okay, we can see加到518. Okay. Now let me check the water tank. Now just it's mean 517. 18 is mean water level should be 440. So let me check, it's 440. Okay, yes, 440. Display 517. So there is 1 millimeter difference. It's okay, it's a good accuracy for 2-meter range sensor. Okay, we continue to increase water to 530. Okay. Now 529. Now water should be 450 millimeter. So let me check the water tank is 450. Is it correct? Yes, it's 45 cm. Okay, now from this testing we can, there is 1 millimeter difference. So from the testing we can see the helical fuel sensor's measurement result is good, and also inside the accuracy. Now the second step is tell you how to change the density to density 0.85 to 0.84. Before change the density, let me first check density. Let me check the table, the calculation table. Okay. Now this sample testing, the test sample is original calibration density is 0.85, and again is soft gain. Okay. Now from here to change the density, the original gain is 1.0, and the original density is 0.85. Now we need to change the density from 0.85 to 0.84. So we need to input the gain is use D1 0.85 to divide D2. Divide D2, and we can get the gain is 1.0119. So we need to put this data, this number, into the software, the gain format. Okay, let's try. Now, 9. Okay, you can see, input this gain. We are right or okay, finish. Now the sensor is changed the density to 0.84. So the result also changed. You can see from 530 changed to 536. This is the same from the table. You can see the middle display 0.84 density and 536 millimeters. The original, you can see the 530 millimeter, and the water is 450. Okay, so we can check the water if it is 450. Yes, it's 45 cm. So the density changed correct, and get the result is also correct. So it's very easy to change the sensor's density by the software. If you want to change back original, it's also see the second formula. Now you can input. You can just need to input 1 where back original. Okay. Alright. Now you can see it's back original 513. Now there one difference. Okay. Water level the same. 45 cm. Okay, this is the second testing for the density change. Okay, after you finish change, okay, let's change it. Alright. Then please back to the software first page. Okay, and please connect users server. Okay, to serve your changes. By this way, we can close the software. Okay, we reopen. Please reopen. Okay. Now you can see the sensor's configuration original. Let's first search the sensor. The bound rate is 19200. Okay, find the serial port and search. The ID is 15. Okay. Now the data upload software. Now you can see. Okay, let's do change. Now the read is 536 millimeter and based on density 0.84. Okay, now we change this little changes. How about the reading? Please engineer, please okay, change the level to 524 millimeter. So the water tank should be display 44 cm. Okay. 524 厘米。可以吗？ Okay, there 1 millimeter difference. 524 now it's reading 523. Okay, so it's the table should be 44 millimeters water tank. 44. Yeah, it's right. 44. Okay, 44, correct. So the display fuel lever is 1 millimeter difference with the actual lever. The actual lever should be 524 millimeter. Okay, you can see it all 16 times data reading. Continue. The output is very stable. Now you can see 30001. The orange color is the data reading. Continuous. And 2, 3, 4, 5, 6, 7, 8 also it's the different time connection the reading of the sensor data. Okay, now let's continue. We'll reduce water level to 43 cm. It means the fuel display should be 512 millimeter. Okay. So water tank is 43 and fuel level should be 512 millimeter. Let's check 512. Yes. So here 43. Yes, very good. So the sensor is testing with a good accuracy and also change the density. It's perfect. Okay, today's testing finish. Hope you can understand our testing and very easy, and the data display directly show you the water tank level and the fuel level display on the software. So from the table, calculation table based on different density relation. Also here change the density from 0.85 to 0.84. Also back original 0.85. Okay. Thank you.